Internet Protocol Suite. The Internet Protocol Suite, commonly known as TCP/IP, is a framework for organizing the set of communication protocols used in the Internet and similar computer networks according to the functional criteria. The foundational protocols in the suite are the Transmission Control Protocol (TCP) and the User Datagram Protocol (UDP) and the Internet Protocol (IP). Early versions of this networking model were known as the Department of Defense (DoD) model because the research and development were funded by the United States Department of Defense through DARPA. The Internet Protocol Suite provides end-to-end data communication, specifying how data should be packetized, addressed, transmitted, routed, and received. This functionality is organized into 4 abstraction layers, which classify all related protocols according to each protocol scope of networking. An implementation of the layers for a particular application forms a protocol stack. From lowest to highest, the layers are the link layer containing communication methods for data that remain within a single network segment link, the internet layer providing internetworking between independent networks, the transport layer handling host-to-host communication, and the application layer providing process-to-process data exchange for applications. The technical standards underlying the Internet Protocol Suite and its constituent protocols are maintained by the Internet Engineering Task Force (IETF). The Internet Protocol Suite predates the OSI model, a more comprehensive reference framework for general networking systems. History, further information, history of the Internet. Early research, initially referred to as the DoD Internet Architecture Model. The Internet Protocol Suite has its roots in research and development sponsored by the Defense Advanced Research Project Agency (DARPA) in the late 1960s. After DARPA initiated the pioneering ARPANET in 1969, COAST established a networking working group which developed the host-to-host protocol, the Network Control Program (NCP) in the early 1970s. DARPA started work on several other data transmission technologies, including mobile packet radio, packet satellite service, local area networks, and other data networks in the public and private domains. In 1972, COAST joined the DARPA Information Processing Technology Office, where he worked on both satellite packet networks and ground-based radio packet networks, and recognized the value of being able to communicate across both. In the spring of 1973, COAST joined CON to work on open architecture interconnection models with the goal of designing the next protocol generation for the ARPANET. They drew on the experience from the ARPANET research community of an international networking working group, which COAST chaired. By the summer of 1973, COAST and COAST had worked out the fundamental reformulation in which the differences between local network protocols were hidden by using a common internetwork protocol, and instead of the network being responsible for reliability, as in the existing ARPANET protocols, its function was delegated to the host. Credits COAST and COAST, designers of the Cyclades network, with important influences on this design. The new protocol was implemented as the Transmission Control Program in 1974. Initially, the Transmission Control Program, the Internet Protocol, did not then exist as a separate protocol, provided only a reliable byte stream service to its users, not the datagram. As experience with the protocol grew, collaborators recommended the division of functionality to layers of distinct protocols, allowing users direct access to datagram service. Advocates included COAST, who needed it for its packet voice work, of the University of Southern California's Information Sciences Institute, who edited the Request Commons, RFCs, the technical and strategic document series that has both documented and catalyzed the Internet development, and a research group of COAST and COAST. COAST stated that we are screwing up our design of the Internet protocols by violating the principle of laws, the principle of layering. Encapsulating of different mechanisms was intended to create an environment where the upper layer could access only what was needed from the lower layers. A monolithic design would be inflexible and lead to scalability issues. In version 3 of TCP, written in 1978, COAST and COAST split the Transmission Control Program into 2 distinct protocols: the Internet Protocol as a connectionless layer and the Transmission Control Protocol as a reliable connection-oriented service. The design of the network included the recognition that it should provide only the functions of efficiently transmitting and routing traffic between end nodes, and that all other intelligence should be located at the edge of the network. In the end nodes, this design is known as the end-to-end principle. Using this design, it became possible to connect other networks to the ARPANET that used the same principle, irrespective of other local characteristics, thereby solving COAST and internet working problem. A popular expression is that TCP/IP, the eventual product of COAST and COAST work, can run over 2 thin scans cans and a string. Years later, as a joke, the IP over codes carried a formal protocol specification was created and successfully tested. DARPA contracted with BBN Technology, Stanford University, and the University College London to develop operational versions of the protocol on several hardware platforms. During development of the protocol, the version number of the packet routing layer progressed from version 1 to version 4, the latter of which was installed in the ARPANET in 1983. It became known as Internet Protocol version 4, IPv4, as a protocol that is still in use in the Internet. Alongside its current successor, Internet Protocol version 6, IPv6, early implementations. In 1975, a two-network IP communications test was performed between Stanford and University College London. In November 1977, a three-network IP test was conducted between sites in the US, the UK, and Norway. Several other IP prototypes were developed at multiple research centers between 1978 and 1983. A computer called a router is provided with an interface to each network. It provides network packets back and forth between them. Originally, a router was called an achievement way, but the term was changed to avoid confusion with other types of achievement ways. Adoption. In March 1982, the U.S. Department of Defense declared TCP/IP as the standard for all military computer networking. In the same year, Norsaw and Coates Research Group at University College London adopted the protocol. The migration of the ARPANET from NCP to TCP/IP was officially completed on Flag Day, January 1, 1983, when the new protocols were permanently activated. In 1985, the Internet Advisory Board, later Internet Architecture Board, held a 3-day TCP/IP workshop for the computer industry, attended by 250 vendor representatives, promoting the protocol and leading to its increasing commercial use. In 1985, the first Interop conference focused on network interoperability by broader adoption of TCP/IP. The conference was founded by Coase, an early Internet activist. From the beginning, large corporations such as IBM and DEC attended the meeting. IBM, AT&T, and DEC were the first major corporations to adopt TCP/IP. This despite having competing proprietary protocols in IBM from 1984. Coase Group did TCP/IP development. They navigated the corporate parties to get a stream of TCP/IP products for various IBM systems, including MVS, VM, and OS/2. At the same time, several small companies such as FTP Software and the Wollongong Group began offering TCP/IP stacks were written single-handedly by a few programs of IBM researchers who wrote TCP/IP stacks of VM, CMS, and OS/2 respectively. In 1984, Coates at MIT wrote an NTCP multi-connection TCP which runs atop the IP packet driver layer maintained by Coates MIT in 1983. Coates leveraged this TCP in 1986 when FTP Software was founded. Starting in 1985, they created the multi-connection TCP application from ham radio systems KA9Q TCP. The spread of TCP/IP was fueled further in June 1989 when the University of California, Berkeley agreed to place TCP/IP code developed for BSD Unix into public domains. Various corporate vendors, including IBM, included this code in commercial TCP/IP software releases. Microsoft released a native TCP/IP stack in Windows 95. This event helped cement TCP/IP's dominance over other protocols on Microsoft-based networks, which included IBM's Systems Network Architecture, SNA, and other platforms such as Digital Equipment Corporations, DECLET, Open Systems Interconnection, OSI and Xerox Network Systems, XNS. Nonetheless, for a period in the late 1980s and early 1990s, engineers, organizations, and nations were polarized over the issue of which standard, the OSI model, or the Internet Protocol Suite would result in the best and most robust computer networks. Next is formal specification and standards. Inshallah.